everyone, in the previous video we have discussed W hash W reverse, so please see that video. This is a continuation to that video. So in this video we are discussing how to design a Turing machine W reverse. In the previous video there was a middle marker, that is hash, but here this is lacking. So computer can't decide where you have stopped till where you have assumed a W. Okay, so for that the Turing machine or all the machines will use a marker here, middle marker here. So if no marker is giving, the Turing machine will assume it as what? Null. Then only you can design the Turing machine. So here also I am assuming W I take as AB and null marker is inserted in between that, and then it becomes what? BA. Okay, blank is inserted to here. Okay, so that's the logic behind W reverse. If there is no middle marker, you must insert a middle marker into it. Okay, then only it will work clearly. All other cases are same. Here only null is looking for, there we have looked for what? Hash. So same diagram. I think you can easily do it correctly. When you see my video, it will be a repetition, and it will be a repetition for all other state except for the null. So it will be very clear, your previous video and this video, when you see it together. Okay, so when I see A, I make it as X and I move what? Forward. Okay, so then whenever I say A and A, I make it as A and move forward. When I see B, I make it as B and move forward. Okay, so then when I see null, I make it as null and move forward. Okay, so here I have made it as what? X and I move forward. And when null, after null, what all things comes? B comes, A comes, you have to reach up to where? Blank. So we must bypass that also. Okay, so B comes, I make it as B and move what? Forward. A comes, I make it as A and move forward. And when blank comes, I make it as blank and move what? Backward. Okay, so when I move backward, I must get the first A after B. Okay, so I will write it what? When A comes, since we are starting here for A, we must make transition for here what? A comes, I make it as X and I move what? Backward. Okay, when I move backward, I can see what? B's are there, or A will be there. Whole combination will be there. Since here are only B's, since we have taken only a small string, but there will be A's, B's also, all will be there. So A there, A comes, I move but backward. B there, B, make it as B and move backward. And if null comes, I make it as null and move what? Backward. So once again I am saying, if null, since we have checked for here one occurrence, don't check it repeatedly, because only one null will be there between blank and blank. If only one null is there, this machine will move to up to here, otherwise it will not move, because there is no transition here repeating for what? Null. So here A, when we start from here and when we reach here, there will be only one null checking is possible, and it strictly says that only one null is there. There is no looping of null, so there will be not null in between. If there exists null, your machine will be stuck somewhere here. Okay, so that not need to be checked again and again. If you want to check, you can make it as other state. And after we have reached here, we have to check for what? X we have to check. So X, when comes X, I make it as X and I move what? Forward. And after X there is B here. If it is same A, you must go to this loop again. If now I am checking for the next B, so B comes, I make it as X and I move what? Forward. Okay, so same conditions repeating. Okay, A comes, I make it as A and move forward. B comes, I make it as B and move forward. And when it is null, I make it as null and move what? Forward. Okay, and then what happens, we have to bypass after null, we have to bypass b's, a's, and also x will also be there, so that also must be bypassed. B comes, make it as b and move forward. A comes, I make it as a and move forward. If x come, I make it as x and move forward. So right here also, okay. So every time in the previous video also I checked, this and this will be exactly same, difference will be here and this here only, all others will be exactly same. Okay, x I move forward, and when I see blank, I make it as blank and move backward. When I move backward, I will see x, isn't it? When one time it has been matched, I will see x. That x should be what? Bypass. So here also bypass it. Whenever you see new symbol, do the updations in the both side also. So I move what? Backward. So x comes, x, I make it as x and move what? Backward. And when I see here starting with b, I must see here b. So b, I make it as x and move what? Backward. When I am moving backward, I will see what? Null I will be seeing, that to be bypassed. A will be seeing, that to be bypassed. B will be seeing, that to be bypassed. Then what we have to take care of? We have to take care of only x. Okay, so x saying, I make it as x and move forward. Okay, after this what will be the x, and here also x will be the, and look at this logic. After whole matching, where will be the pointer? Pointer will be the in the cell preceding the null. Okay, pointer will be in the cell preceding the null. If it is x correctly matched, the pointer will be in the preceding cell, that will be what? X. If it is not correct, it will be there will be some difference. So if correctly matched, the null after before null, there will be what? X. Okay, so there will be the pointer reaching. Okay, so what to do? So you have to bypass, after that you have to bypass it. Okay, so first the pointer is here, first we must take what? Null. Okay, so null comes, I make it as null and move what? Forward, since we have to reach here, isn't it? The previous video also, when we reach blank, we said yes, correctly matched, no other symbols here, only the updation symbols. Updation symbols means what? X and y there between b and x, then it will be what? Correctly matched. So here null to be bypassed, only one time null will be occurring, and then we have to check for what? X comes, I make it as x and move what? Forward. Okay, then whatever times x comes, I make it as x and move what? Forward. Then what happens? Blank comes, isn't it? So blank comes, I make it as blank and move what? Backward, and I make it as what? Accepting state. Okay, so every time if the expression is correctly matched, from the blank it will have been reached up to here, isn't it? Every time in the last updation, x will be the pointer. For example, if I am matching, for example, if you have matched the first a and b, for example a b null, b a blank. Okay, the first time you have matched, you have made this was x and this was x. Okay, up to here you have made, up to here when you look, you have made this as x, and from there the pointer will be moving to bypassing b, bypassing null, and bypassing again b. Okay, so you must have reached up to here. That is what I am saying. The pointer will be where? Pointer will be, if the correctly matched pointer will be in the x before the null. So the correct logic is that if it is correct, nulls before cell will contain what? X. If it is not correctly matched, it will be in the in between there will be some b's in between null and x also. So that's the condition where the violation happens. Sometimes it will be here also. So if it is not correctly matched, it will be somewhere there. But if it is correctly matched, if all the symbols are correct, the expression or the pointer will be pointing to the cell before the null, and it will be certainly what, x. Okay, so that must be in your mind. If it is correctly matched, the pointer will be pointing to the cell before null, and it will be certainly x. So first you have to bypass null, because after x it will be null, and you then bypass x, then you reach blank, you can what, accept it. So that's the logic of w reverse. So I think by this 2 video you have get an idea how the Turing machine will respond to palindromes. In the next video we can see w. So duplicate strings. If w comes, next w comes, how the Turing machine will respond. Okay, thank you, keep watching.